Perfect.
Yeah, so I will talk a little bit like about my previous experiences with starting with AWS and all the bad mistakes we did in the past when I started with AWS back in 2018. Like I was like almost coming freshly out of university with some master's degree, but never really worked before, but landed a job in consulting. And then, yeah, actually got a job in a pretty big project at some German car manufacturer. And they were starting to move their infrastructure from on-premise to AWS. And yeah, I was on the team doing this. And our first two challenges were actually migrating the core back into AWS, like with avoiding any downtime at all, and in parallel also like building a service from scratch with just a few requirements coming from the management, but we were completely free to decide what to use. So we saw, yeah, there's AWS Lambda, we don't have to manage containers or infrastructure. That sounds pretty awesome. And there's also DynamoDB, which is also completely managed. It scales endlessly. You can just pay for what you use. Let's also use this one. And yeah, everything combined is just no servers, everything is managed. We don't have to worry about anything else besides our business code. This will be a pretty easy job. So we came up with, yeah, we pretty much just need a gateway, some Lambda functions with Node.js, because we read in the documentation, yeah, Java is bad. We're Java experts, but we can surely use JavaScript also and start with diffs, even we don't know any AWS at all. And we can just start with DynamoDB because it's just a NoSQL database. So that's good to go. So this was our expectation, and pretty much the list in the end looks like, yeah, how to avoid pain. Got some AWS expertise. We had nothing. Then also know your tech stack. We didn't because we don't know any AWS, and we also know nothing about Node.js. Then the next thing was about room for errors. There was basically none because like it was on a really tight time schedule, and yeah, the requirements were also not too clear in the beginning. And we didn't really plan well because yeah, we just started with our tech stack. We thought it's best, even though it had no clue. And basically, yeah, we couldn't fulfill any of the requirements to like avoid a lot of pain. Yeah, what we came up with was like, yeah, starting to build something we had no clue about, but we made a pretty steep learning curve, and it took us just a few weeks to get something up and running, which looked good in the first place, but wasn't a really good solution. And it took us a long time to figure out what's really necessary to build a serverless application, which is really reliable and stable. So this will be just a collection about like all the mistakes and assumptions we had in our team over this like 1.5 years or something, and all the things we've learned and stumbled upon. And yeah, all the mistakes you shouldn't do when you start with AWS Lambda. Yeah, the first one and pretty obvious one is like if you're starting with some new tech stack or just starting with the cloud or AWS, it's probably a good idea to not start in parallel with a complete new language. Is probably very, very bad. Yeah, AWS Lambda abstracts away a lot of the underlying infrastructure, but it has a lot of things you need to know in the beginning, and it's probably not good if you have no clue about the language you're using. So we went into like a lot of big troubles because we didn't even knew how promises work and how the event loop is working, and that the Lambda execution is like freezing at the end when it reaches the code stack, but if there are events stuck in the loop, they will be processed if the same instance is invoked in the next time. And then we had some really bad scenarios where we couldn't figure out what's happening at all because it wasn't deterministic. It's just happening sometimes, because at other times the instance was deprovisioned by AWS. And yeah, we had no clue about Node.js. And if we did this in another language where we had more proficiency, this couldn't have happened in the first place. Yeah, then we also read about, yeah, there are some cold starts, but you just need some event bridge, CloudWatch rules for health checks, and then this will be completely fixed, which is, yeah, like obviously it's not the case. You will get rid of a lot of cold starts and you can improve this, but there will be some deprovisioning by AWS. Like it will happen, and if you have customer-facing functions, there will be some slow requests, and it's really hard to avoid, and you have to put a lot of effort into this. Like Tobi wrote a great article about this, about some time series forecasting. So you can spin up required instances based on some previous statistics, which is really great, but just having some CloudWatch rules for health checks won't do it to make it really properly work. And then the most critical thing we had was like thinking that DynamoDB is just some NoSQL solution, which we had no clue of. So we designed our schema first, implemented all the stuff, and then like weeks after this thing live, we really thought about our needed access patterns in the future. And that's like a really, really great pain, because at DynamoDB, you should be aware of your access patterns in the first place and should design everything around the access patterns, so you know what do you want to query in the future, because it's like really hard to change something fundamentally in later stages. So this was pretty bad. We did some horrible solutions with like adding some lookup tables to query some NM relationships in DynamoDB. So building some SQL around NoSQL, which was super not cool. So like my most like the thing you have to think about is what are your access patterns in the first place, and put some efforts into learning DynamoDB and understand the fundamentals, because you, before putting it into practice and bring some service to production. Then what was also true for us, we thought, yeah, Lambda just works and AWS just works, so we can just do everything synchronously. We don't need any dead letter queues or any SQS at all, because everything will just work. And that's obviously not the case. Like really good architecture should be mostly event driven and not just about synchronous invocation, because some things will fail. And if you're having no queuing system at all, just a lot of events will just be gone and you probably won't even know about this. This brings me to the next point. Like we didn't put any efforts in bringing some good observability in the first place. I think our production service went live without having any, not even any CloudWatch alerts at all. We didn't even think about having some third-party tool for monitoring like dashboard, which will make your life much easier. And we got a lot of errors, which we found out weeks after, because like, yeah, we had obviously no clue what was actually going on. And yeah, most of the stuff were working for us. So how it works on my machine, but for customers, there were a lot of errors, and we didn't find out about this until we started to use some like external tool for observability. Because like CloudWatch, yeah, it also works, especially with X-Ray, but it's not like some stuff you can just spin up and use. You have to put a lot of effort into. Then we also thought, yeah, everything AWS native integrates well, so we will always use this. And then we built our CI/CD with code build and code pipeline, which I wouldn't recommend at all for anybody, and I wouldn't continue with this in the future because it's just so much overhead and the interface is just so horrible. So if you're used to Jenkins or something else, it's just a pain. And even the AWS architect we talked to just told us, please just never use a service if it contains the word code. And I think he's very right about this. Yeah, this brings me to the last point. Like, I'm a huge serverless fan and I'm using it for basically everything, but I think it's not a fits-all solution. Like, you should be really, really aware for your requirements. And there are some use cases where it's probably better to just use some containerized approach with ECS, for example, because Lambda will just introduce a lot of pain for you. And yeah, what's also like more or less obvious, there are a lot of things you will just know if you go deeper in the material, like this thing about running code outside of your handler will run with high memory and virtual CPUs, and it won't be built for the first 10 seconds. I'm still not finding any documentation for this, but it's very true, and it does a lot for your bill and also for your latencies. Then you can do a lot of awesome things, like with the aliases. You can do weighted alias and you could traffic shifting to make like just pointing 10% of your customers to your updated Lambda functions. And we didn't know about all this in the beginning, even though it was already there, because we just blindly started without making some actual plans and going deeper in the material. And yeah, there's also some cost performance optimizations which can be done. So I think like 2 GB of memory allocation is like some perfect trade-off because of like, yeah, you're paying more for the execution, but it's worth because your function will be a lot faster. I think there was also some nice blog article by Tobi about this, where they tried out everything and made some graphs about this. And yeah, it's worth spending time for this and not just starting blindly. And yeah, obviously there's a lot more to like explore and optimize.